Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving past paper questions of IGCSE Physics 0625. Currently we are solving topicals for paper 2. Inshallah, we will get to paper 4 as well. So we've covered 7 topics up till now, and today the topic that we are covering is deformation. This is also relatively a straightforward topic. Not much of concept is required. There is a small concept, and if you cover it, then you will be able to answer any question related to this topic. Okay, so inshallah, I'll try to clear that concept so that you can do any question related to this. Okay, ji? So let's begin. But before we begin, kindly subscribe the channel and press the like button. And if you have any questions, queries, kindly shoot them in the comment section. And if you find anything helpful in the video, kindly remember me in your prayers. Thank you. So let's start. Question number 1. The spring has an unstretched length of 3 centimeters. When a force of 60 Newton is applied to the spring, its length increases to 5 centimeters. The limit of proportionality is not exceeded. What is the spring constant of the spring? Okay. Now, we know that this is the concept that you need to understand. That force, the Hooke's law states that all this topic of deformation is based on Hooke's law, which states that when a force is applied, the extension in the spring is directly proportional to each other, but until the limit of proportionality is reached, the spring is always going to go back to its original position once the load has been taken off from the spring, until and unless the limit of proportionality is not exceeded. After the limit of proportionality is exceeded, the spring, wire, or anything that is used to hang the loads is not going to go back into its original position. The force is always directly proportional to extension. Now, when we have to change the sign of proportionality into an equal to, we need to add a constant. So K is the constant in this case. So this is our equation which we will use to solve questions regarding deformation. So it has the question tells us that a force of 60 Newton has been applied. It tells us that the unstretched length of the spring was 3 centimeters, and when a load was applied, the length increases to 5 centimeters. So the extension, so just understand this as well, that first the spring had a length, a natural length you might say, of 3 centimeters. When a load of 60 Newton was applied to it, the length became 5 centimeters. So you need to find out the extension first, okay? So extension is not 5 centimeters. It is the increase in length. There is a difference between increase in length and extension. Okay? Extension means that there was some length before, and then when the load was applied and there was an increase in the length, that increase in the length is the extension. So this would be the extension, just this, not this naturally extended portion of the spring, which is 3 centimeters. So extension would be the final reading minus the initial reading of the spring, that is 2 centimeters. Theek ho kya ji? So when we will apply this in the formula, force is 60 newtons, K is the constant, and extension is 2 centimeters. So 60 divided by 2 is going to give us the value of this spring constant. So this is going to be 30. Okay. So I'm going to be doing this again and again. So inshallah at the end of the video you will be able to grasp the concept inshallah if you haven't done so in just the first question. The extension load graph is shown. The unstretched length of the spring is 17 centimeters. When an object is suspended from the spring, the length is now 19.2 centimeters. What is the weight of the object? Okay. Now, we know that what we need to do is, before we do anything else, we know that the unstretched length of the spring, when nothing was applied, the natural length of the spring is 17 centimeters. ठीक है जी? And when the load is applied, so the length extends and it now is any load that we have to find. We don't know what the load is. So that is the increase in the length is 19.2 centimeters. Okay. So first, what we need to do is we need to find the extension. Delta x. So what is extension? That is the increase in the length minus the natural extension of the spring. Okay. So that is 19.2 minus 17. That gives us 2.2 centimeters. So this is the extension. So what we are going to do is, we will see that when the extension is 2.2 centimeters, what is the load that corresponds to that extension? ठीक है जी? So 2 point. So these squares are not that visible, so I need to see. I think that 1, 2, 3, 4, and 5. So 1 square is equal to 2. So this is where 2.2 is going to be. So we will see that which load corresponds to this. What do we say? So this is going to be 3 newtons. ठीक है? The extension of 2.2 corresponds to a load of 3 newtons. ठीक है जी? The 3 is going to be our correct answer. Actually, the divisions and the graph is not that visible in this figure, but anyways, inshallah, when you will be doing the CIE paper, so you will have a clear graph. Okay. Now question number 3. An experiment is done to determine the spring constant for the spring. Different loads are hung from the spring and its length is measured for each different load. The graph shows how its length varies with load. Okay. What is the value of the spring constant? Acha ji. Now we see that this is the gradient of the graph. The gradient is going to this is the length of the spring, this is the load of the spring. Acha, keep in mind the fact that this is the length of the spring and not the extension. ठीक है जी? Please keep in mind this fact. Kindly see what is being depicted on x and y axis. Here there are loads and here there is length of the spring and not the extension. Okay, so in order to see the constant for it, we need to find the gradient. Okay, we already know how to find the gradient. We take 2 points. So 1 point, clear-cut point can be 20 and 4, and 1 point can be 4 and 0. These are 2 clear-cut points, so I'm just taking these. So in order to find the gradient, we already know that gradient is equal to rise over run. ठीक है, तो what is the rise? y2 minus y1, and what is the run? x2 minus x1. So this is going to be our y2, and this is going to be our y1, and this is going to be our x2, and this is going to be our x1. So this is going to be 4 minus 0 by 20 minus 4. This is going to give us 4 over 16. So 0.25 Newton per centimeter is going to be the answer. So the gradient in a load length graph gives you the spring constant. Alright, just remember this. Okay, so B is going to be our correct answer. Okay. Question number 4. A student wishes to determine the spring constant of a spring where it obeys Hooke's law. Different loads are hung from the spring and its length is measured for each different load. The table shows the result of the experiment. Weights of the load, yani load, and length of the spring is being given. Okay? The spring obeys Hooke's law, so that this means that force is directly proportional to extension. Okay? Now keep in mind the fact that over here length is being mentioned and the extension is not being mentioned. ठीक है जी? Okay, so please keep an eye on this thing. ठीक है? अगर आप इस पे नजर रखोगे तो you इंशाल्लाह can ace this topic. बस ये याद रखो कि extension शो हुई है या length of the spring शो हुई है. ठीक है? तो हमको ये पता चल रहा है कि natural extension of the spring is 12 centimeters. How do we know that? We know that when a zero load is being applied, so it extends to 12 centimeters. ठीक है? When no load is being applied. So a natural extension is 12 centimeters. We already know that. What is the value of the spring constant? So we can take any of these values. ठीक है? For example, हम ले लेते हैं ये अगली वैल्यू ही ले लेते हैं, इससे स्प्रिंग कांस्टेंट आराम से निकल आएगा. तो सबसे पहले तो वी नीड टू हैव आवर एक्सटेंशन. ठीक है? We already know that when a load of 2 newtons is applied, so the extension is 20. So extension becomes 20 when a load of 2 Newton is applied. So the natural extension was 12 centimeters. So when we have to find the extension delta x, we subtract the natural extension from the natural length from the extended length. ठीक है ना? So 20 is our extended length and 12 is the natural one. So this is going to give us 8. ठीक है? So for 4 newtons, which is the next value, the extension is going to be 28 minus 12. ठीक है? So this is going to give us 16. So now we can simply and so on. आप इसमें से कोई भी वैल्यू ले सकते हो. ठीक है? मैंने आपको 2 वैल्यूज का बता दिया, इसलिए बताया कि आपको पता चले कि बस ये जो लास्ट वैल्यू होती है इसमें से इनिशियल वैल्यू माइनस करने से आपकी एक्सटेंशन आ जाती है. ठीक है? तो नाउ फाइंड द स्प्रिंग कांस्टेंट. व्हाट वी नीड टू डू इज F is directly proportional to extension. F is equal to K delta X. We have to have a constant if we want to lose this sign of proportionality. The force अभी आपकी 2 newtons थी जब, तो एक्सटेंशन आपकी 8 centimeters थी. So 2 by 8 is going to give us the spring constant, which is 0.25 is equal to K. So 0.25 D option is the correct answer for this question. Question number 5. An experiment is carried out to determine the spring constant for a spring that obeys Hooke's law. A load is hung from the spring and the extension of the spring is measured. Which calculation is used to calculate the spring constant? Okay, we already know that F is equal to K delta X, ठीक है? And to find the spring constant, we would have to divide the force with our extension. So this is going to give us the spring constant. So which option gives us this weight of the load by extension is going to give us this. Okay, the D is going to be the correct answer for this. Pretty straightforward question. If you know your formula, so you will be able to do it, inshallah. Okay, the extension load graph for a spring is shown. Now there is extension and there is load. This is not the length that's increasing of the spring. This is the extension. Okay? The unstretched length of the spring is 15 centimeters. Okay? When an object of unknown weight is suspended on the spring, the length of the spring is 16.4 centimeters. So what is the weight of this object? Okay, now we have the length increase. Okay? So we have to find the load with the help of that. Okay, we know that in order to get our extension, we have to subtract the initial or the natural unstretched length of the spring from the length when this load has been applied. So 16.5 is our final length of the spring and 15 is the natural extended length of the spring. So this is going to give us 1.4 centimeters. ठीक है, extension अब हमारी 1.4 है. Now we will look in the graph and see where the extension of 1.5 is. अच्छा, I think now this is equal to 1 है ना? 1, 2, 3, 4, 5. So this is where 1.4 is. ठीक है, 1.4. This division gives us 1.4. So now we will see the corresponding load with this line. I hope you can see this. मैं color नहीं तो change कर लेती हूँ. Okay, so here is our corresponding load with this extension, which comes out to be 1, 2, 3, 4, 5, 3.5 newtons. ठीक है जी? So this is the correct option for it. Okay. Now moving on to question number 7. The graph shows how the length of the spring changes when stretching forces increased. In the Hooke's laws region, what is the spring constant for this spring? Okay. Acha. When we are given this a graph of load and length of the spring, so it's not load and extension, is the length. Sorry, extension, it's the length of the spring. So a clear-cut point on the graph we can see is when a force of 5 newtons is being applied. So here we can see that the length of the spring to be 20. ठीक है? When a force of 5 newton is being applied, ठीक है, तो लेंथ हमें 20 मिलती है. ठीक है, हमें नजर आ रहा है ना क्लियर कट लेंथ. और तो कोई हमें वैल्यू क्लियर कट नजर नहीं आ रही है इस स्ट्रेट लाइन की, तो यहाँ हमें क्लियर कट नजर आ रही है. We can also see in the graph that the length starts from 5 centimeter. So that is the length of the spring without any load being applied. ठीक है? So the extension would be calculated as this final length minus the initial length. ठीक है? So final अभी हमने यहाँ देखी कि 20 है और इनिशियल हमने देखा कि 5 है, तो दिस इज गोइंग टू गिव अस एन एक्सटेंशन ऑफ 15 सेंटीमीटर्स. So now it's pretty much simple. F directly proportional to delta x, that is extension. F is equal to K delta x. We have to find the spring constant. So when a force of 5 Newton is being applied, as we've seen in the graph, so an extension of 15 centimeters is seen. So 5 over 15 is going to give you the spring constant. 5 3s are. What is 1 divided by 3? It is going to be 0.33 Newton meters. ठीक है जी. ये प्लीज याद रखो कि ये लेंथ है, एक्सटेंशन का ग्राफ नहीं है. When there is an extension and a load graph, the gradient gives you the spring constant. But when it's a length and a force graph, तो kindly don't fall for it कि gradient से मैं निकाल लेता हूँ. This is not going to give you the spring constant. ठीक है. Question number 8. A load is hung from a steel wire. The load is increased. The length of the wire increases until the limit of proportionality is reached. The load is now increased slightly. What happens? Okay. Now we know that the Hooke's law states that the load is force is directly proportional to the extension until the limit of proportionality is reached. After this, when the limit of proportionality is reached, force is not proportional to the extension. ठीक है? After the limit of proportionality has been crossed. Limit of proportionality इसको कर लेते हैं, has been crossed. ठीक है जी. ये कॉन्सेप्ट आपको समझ आ जाए अगर, तो this is going to be a piece of cake for you. The option A states that the extension of the wire increases and the wire no longer obeys Hooke's law. Yes, this is the correct answer because I've just explained this fact to you. The extension of the wire decreases. Extension कभी भी decrease नहीं होगी when you will increase the load. ठीक है? Extension of the wire increases and it obeys Hooke's law? No. The extension of the wire does not obey Hooke's law when the limit of proportionality is reached. ठीक है? The extension of the wire decreases. Extension of the wire is never going to decrease when a load is being applied. ठीक है? तो question A is the correct answer. Okay, question number 9. A spring is stretched by hanging a piece of metal from it. What is the name given to the force that stretches the spring? Okay, हम interchangeably use करते हैं force को, load को और weight को. ठीक है? So D is going to be the correct answer. Pressure has nothing to do with it. Mass is the amount of matter in the body and this does not correspond to the force. Weight corresponds to the force. And friction भी यहाँ पे किसी काम का नहीं है. So the correct answer is option number D. Okay. Question number 10. A spring which obeys Hooke's law has an unstretched length of 10 centimeters. So this is the initial or natural length. A load of 20 Newton is hung from the spring. The new length of the spring is 36 centimeters. What is the spring constant? Okay. In order to find the spring constant, we need our extension, and extension comes from subtracting the natural extension from the extension, final extension when the load has been hung. The 36 minus 10 is going to give you 26 centimeters. So we know the force already, which is 20 newtons. And the extension for 20 newtons is 26 centimeters. So 20 over 26 centimeters is going to give you 0.76. It can be rounded off to 0.77. So B is the correct answer. Okay, question number 11. Different loads are hung from a spring. The diagram shows the length of the spring with and without the loads attached. What is the extension of the spring when the load of 400 newtons is applied? So this is the natural extension, 20 centimeters. This is the extension when the load of 400 newtons is applied. So the increase in the length is 65 centimeters. So our extension is going to be 65 minus 20 centimeters, and this is going to give us 45 centimeters. Okay? This we've done so many times before. So D is the correct answer. Okay. Question number 12. A scalar quantity has just magnitude but no direction. That we already know. Vector quantity has direction as well as magnitude, whereas the scalar quantity just has magnitude but no direction. Okay, ji? Question number 13. A student measures the length of the spring. She then hangs different weights from the spring. She measures the length of the spring for different weights. The table shows her result. What is the extension of the spring when the weight hung from it is 3 newtons? Okay. Now we already know that the natural extension of the spring is 520 millimeters. And the extension of the spring when a weight of 3 newtons is applied is 533 millimeters. So our extension is the final increase minus the natural or the initial increase. ठीक है, तो फाइनल हमारा 533 है लेंथ, और जो अनएक्सटेंडेड लेंथ है स्प्रिंग की वो 520 है. तो 533 minus 520 gives you 13 millimeters as the extension. ठीक है, आपको एक्सटेंशन निकालनी आती हो फिर आप कोई भी क्वेश्चन कर सकते हो. Now question number 14. A student adds weight on an elastic cord. He measures the length of the cord for each weight. He then plots a graph from the result as shown. What has he plotted at the vertical axis? If this is the weight, ठीक है, तो this is going to be the measured length minus the original length, which is the extension. ठीक है? So that is what he is plotting. Not just measured length, not just original length. Measured length plus original length नहीं है. It is measured length minus the original length. ठीक है जी? Question number 15. The diagram shows a steel spring and a graph of its length against the load applied to it. Okay. What is the extension of the spring when the load of 20 newtons is applied to it? ठीक हो क्या जी? Okay. पहले, so the original length of the spring is almost 4.24, 4.5 or 6. ठीक है ना? 4.6 इसको करते हैं. ठीक है, तो original length unextended is 4.6. ठीक है, and when a load of 20 Newton is applied, ठीक है, तो the new length would be corresponding to this. So 20 के corresponding length जो बन रही है that is 8 centimeters. ठीक है, तो what is going to be the extension? Extension delta x is the value after extension, that is 8, minus the natural extension, that is 4.6. मुझे लगता है ये 4.6 नहीं है. अगर हम देखें तो 4. ये 5 है एक्चुअली. 4.2, 4, 6, 10. फिर 5 है. Middle value is 5, not 4.6. 8 minus 5 is the extension. So this is going to give us 3 newtons. ठीक है जी? So A is our correct answer. अच्छा जी. Question number 16. A student adds weight to an elastic cord. He measures the length of the cord for each weight. He then plots a graph for the results as shown. So we've done this before as well. If this is weight, so this is going to be the extension. And what is extension? Extension is the measured length minus the original length. So C is our correct option. Okay. Question number 17th. Objects with different masses are hung on the spring. The diagram shows how much spring stretches. So this is the unstretched, natural stretch, 10 centimeters, and this is when 100 grams is suspended, so it becomes double. So when there is another extension of 10 centimeters, as we can see over here, ठीक है? तो यहाँ पे mass क्या होगा? ठीक है? So it's going to be simple कि अगर 10 था और 100 grams का weight apply हुआ है, since we know that force is directly proportional to the extension, so अगर 100 grams का weight होने से extension जो है आपकी वो 10 centimeters हुई है, यानी spring 10 centimeters ग्रो किया है, तो फिर अगर वो 30 ग्रो किया है तो obviously इसका double होगा, which is going to be 200 grams is going to give you a stretch of 30 centimeters. यहाँ extension 20 minus 10 centimeters की थी when 100 grams was being applied. और यहाँ जब 30 minus 10 20 centimeters की है, so this means कि यही डबल हो गया होगा, so 200 grams हो गया होगा ये. ठीक है, ये तो सिंपल आपका तरीका है. आप इसको you can always find this with applying the rate concept of rate जो मैथमेटिक्स में हम करते. Okay, so now question number 18 states that a force acts on a moving rubber ball. Which of these changes could not happen to the ball because of the force? Okay. Change in direction. Direction can be changed because of the force. A change in mass. Yes, the mass doesn't change because of the force. So this is not the correct answer. Na? The change in shape भी हो जाती है, change in speed भी हो सकता है. Only the mass doesn't change. ठीक है? Moving on to question number 19. An experiment is carried out to measure the extension of a rubber band for different loads. The results are shown. Okay, which figure is missing from the table? Okay, this is the load, this is the length, and this is the extension. Okay, we already know that extension is equal to final increase in the length minus the initial unstretched length. So अगर हमें यहाँ की length find करनी है, this thing, so we can always use the extension for it. ठीक है, extension for it is 2.1. और जब कोई भी load suspend नहीं हुआ था तो natural extension is 15.2. So 2.1 plus 15.2 is going to give you this value, which is going to be 17.3. So a value of 17.3 is missing. So option B is the correct answer. Okay. Question number 20. An object in the diagram is acted upon by two forces as shown. What is the effect of these forces? The object moves to the left with a constant speed. Okay. The object moves to the left with a constant acceleration. The object moves to the right with a constant speed. The object moves to the right with a constant acceleration. Okay. Now, as these forces are in the opposite direction, so हम 3 न्यूटन में से 2 न्यूटन को माइनस करेंगे to see which force remains. 1 न्यूटन की force इधर रह जाएगी. ठीक है, तो यहीं से बात आगे बनेगी. This will be cancelled by 3 न्यूटन. ठीक है, and because we know that the forces are in opposite direction but are not equal in magnitude, तो कांस्टेंट जो स्पीड है वो तो गोज आउट ऑफ द विंडो. ठीक है, तो कांस्टेंट स्पीड तो नहीं होगी. कांस्टेंट स्पीड तभी होती है जब फोर्सेस ऑपोजिट डायरेक्शन में और सेम मैग्नीट्यूड में काम कर रहे होते हैं, ठीक है। तो फिर D is going to be our correct answer कि acceleration भी होगी और right की तरफ object move करेगा. Okay, question number 21. Which property of an object cannot be changed by a force? This we already know is mass, because motion, shape and size can be changed, whereas mass, which is the measure of the amount of matter in the body, cannot be changed by any force. So this brings us to the end of this topic. We've covered all the questions for deformation. So inshallah, see you in the next video, where I think we will be doing the turning effect of force. So if you found anything helpful in this video, kindly remember me in your prayers. Thank you, and Allah Hafiz, and like and subscribe the channel please. Okay, thank you.